Welcome back friends in one more video on measures of central tendency, and in this video lecture we will discuss harmonic mean. Dear friends, we have already discussed common modes of central tendency such as arithmetic mean, geometric mean, median and mode in our previous videos. Along with these common measures of central tendency, harmonic mean also play an important role, which will be discussed in this video lecture. Definition of harmonic mean. The harmonic mean can be defined as a value that is the reciprocal of the mean of reciprocals of a set of numbers. Or in other words, we can also say that it is the reciprocal of the arithmetic mean and is calculated by taking reciprocals of the individual observations. And this basic difference of arithmetic and harmonic mean can be understood with this formula, where arithmetic mean can be calculated as x1 plus x2 plus x3 up to xn, and the sum of all the observations can be divided by total number of observations. Whereas harmonic mean can be defined as n over 1 over x1 plus 1 over x2 plus 1 over x3 up to 1 over xn, where x1, x2, x3 up to xn refers to the various values in the observations. Properties of harmonic mean. Harmonic mean gives less weightage to the large values and large weightage to the small values to balance the values correctly. In general, the harmonic mean is used when there is a necessity to give greater weight to the smaller items. The harmonic mean is useful particularly for computation of average rates and ratio. Such rates and ratios are generally used to define relationship between two different types of measuring units expressed reciprocally. There is a great relationship between arithmetic mean and harmonic mean. We can understand this concept with this example. If the prices are expressed in money values, the arithmetic mean will be appropriate to calculate, whereas if the price is expressed in its quantities, one should calculate the harmonic mean. Similarly, in the case of average speed in km per hour, the harmonic mean should be computed. However, the arithmetic mean would be best average if the hours or the time of the journey are given. This concept will be more clear later in this video when we will take some example to understand when and where we have to use harmonic mean and when and where we have to use arithmetic mean. Pros of harmonic mean. It is rigidly confined. The harmonic mean is computed based on every observation in the dataset, that is, it cannot be computed by ignoring any item of the series. The next major advantage of harmonic mean is it gives higher weightage to smaller values in the datasets, since the reciprocal of numerical values is taken for the calculation. It also provides a more reliable result when the result to be achieved are the same for the various means adapted. Certain algebraic change can be made in the formula of harmonic mean for further analysis. It can also be measured when a series holds any negative value. It produces a skewed distribution of a normal one, and it produces a curve straighter than that of arithmetic mean or geometric mean. Now we will see some cons of harmonic mean. Compared to arithmetic mean, it is not easy to calculate and understand. Therefore, it is not popular due to its complex calculation. The harmonic mean is not often used for analyzing business problems, and it cannot be calculated if a dataset have any value which is equal to 0. It is usually a value which does not exist in the series. Since for the calculation of harmonic mean, the higher weightage is given to smaller values in the dataset, so it does not represent the true characteristics of the dataset. It is not advisable to calculate harmonic mean if dataset had both positive and negative values. To understand more details about harmonic mean, now we will see how to calculate harmonic mean in different kind of datasets. First of all, we will see how to calculate harmonic mean in a series of individual observations, such as in example 1, where we have to calculate the harmonic mean of 3, 6, 12, 12 and 18. Here, total number of observation or n value is 5, x1 is 3, x2 is 6 and so on up to xn, that is 18. After putting all these values in the harmonic mean formula, we can calculate that harmonic mean for this dataset is 6.923. Now we will understand how to calculate harmonic mean in a discrete series or a series where the frequency had been given. To calculate harmonic mean for such dataset, we can use the following formula: f1 plus f2 plus f3 up to fn divided by f1 over x1 plus f2 over x2 up to fn over xn. Or in simple word, we can say harmonic mean can be defined as, for a discrete series, summation f over summation f over x. Let's understand this with this example, where a data is obtained from 5 points of a city and the numbers of eggs laid by 5 different species of fishes every month were recorded. We have to calculate the harmonic mean for the given data set. First of all, we will make a table in which in first column we will write the species name, in the second column we will write the number of fishes or the values of f or frequency, and in the third column we will write number of eggs laid every week or values of x. In the next column we will calculate the value of f over x. Here the total number of fishes or summation f will be 26 and the summation f over x will be 0.18525. After putting both these values in the formula of harmonic mean, we can calculate that harmonic mean for this data set is 140.350. Now we will see how to calculate harmonic mean in a continuous series. Just like arithmetic mean and geometric mean, first of all we have to calculate the value of midpoint or x, that can be calculated as the average of lower limit and upper limit. And then this mid value or the average value of the class interval can be used similarly like we have used in the discrete series. Let's understand this concept with this example number 4, where we have to calculate the harmonic mean of plant height for the following data set. So first of all, in the first column we will write the plant height, in the second column we will write the number of plants which comes under that class interval, and the third column we will write the midpoint, and fourth column we will write the values of f over x. Total number of plant in this example or summation f is 100 and the summation f over x in this example is 3.0095. After putting both these values in the formula of harmonic mean, we can calculate that harmonic mean for this data set is 33.2279. Sometimes there is a need to calculate the weighted harmonic mean, where x1, x2, x3 up to x10 are the n observation with their respective weightage w1, w2, w3 and so on up to wn respectively. For such data set, we can use weighted harmonic mean formula, which is summation w over summation w over x. Let's try to understand this concept with example number 5, where a train travels 50 km at a speed of 40 km per hour, 60 km at a speed of 50 km per hour and 40 km at a speed of 60 km per hour. We have to calculate the weighted harmonic mean of the speed of the train taking distance travelled as weight, and we have to also verify that This harmonic mean represents an appropriate average of the speed of train. As we knew that weighted harmonic mean formula is summation W over X, we can calculate the weighted harmonic mean for this data set will be 50 plus 60 plus 40 all over by 50 over 40 plus 60 over 50 plus 40 over 60, or we can simplify it as 48.128, or we can say that the average train speed in this example is 48.128 km per hour. The verification can be done in such a way that average speed will be total distance traveled divided by total time taken, as we knew that the speed will be distance over time. We note that the numerator of equation gives the total distance traveled by the train. Further, its denominator represents total time taken by the train in traveling 150 km. Since 50 over 40 is time taken by train in traveling 50 km at a speed of 40 km per hour. Similarly, 60 over 50 and 40 over 60 are time taken by the train in traveling 60 km and 40 km at the speed of 50 km per hour and 60 km per hour respectively. Hence, weighted harmonic mean is most appropriate average in this case. Let's take some more example. Like in this example, an individual purchased 3 quantities of apples. The relevant data are given below. We have to calculate average price per apple. First of all, we have to decide which kind of average we have to calculate. Since different sums of money spent in various situations are given, we shall calculate weighted harmonic mean to calculate average price. And the formula for weighted harmonic mean is summation W over X. After putting the given values in this formula, we can calculate that weighted harmonic mean for this data set is 1.25. Or in other words, we can say that 1.25 is the average price of individual apple. Let's take one more example, where in a 1000 meters athletic competition, a participant covers the distance as given below, and we have to find out the average speed of that athlete. For first 200 meter, the average speed was 10 meter per second. For next 600 meter, the average speed was 7.5 meter per second, and for last 200 meter, the average speed was 10 meter per second. Like the previous case, we will decide which average we have to calculate. Since speed equal to distance over time and the condition are given in terms of distance travel at various speed, therefore harmonic mean will be appropriate average. Average speed equal to weighted harmonic mean or summation W over X. After putting the values of different speed in this formula, we can calculate that the average speed of the athlete in this data set is 8.33 meter per second. Let's take one more example, where in a factory a unit of work is completed by A in 4 minutes, by B in 5 minutes, by C in 6 minutes, by D in 10 minutes, and by E in 12 minutes. We have to find out what is their average rate of working, what is the average number of units of work completed per minute. At this rate, how many units of work each of them on the average will complete in a 6-hour day. Also find the total unit of work completed. We have to calculate so many things over here. Therefore, we will go one by one. Here the rate to be averaged is time taken to complete a unit of work, that is time per unit of the work done. Since we have to determine the average with reference to a day or which is equal to 6 hours, therefore harmonic mean of the rates will give us appropriate average. So we can say average rate of working will be harmonic mean. And we can calculate by putting all these values in the formula of harmonic mean. And after calculation of harmonic mean, we can say that individual unit on an average takes 6.25 minutes in completion. With the help of this value, we can also calculate the average number of units of work completed per minute by 1 over 6.25, or we can say every minute around 16% of individual unit will be completed. Now in the third step, we will calculate the average number of units of work completed by each person in 6 hours or 360 minutes. It will be 0.16 into 360, that will be 57.6. And the total unit of work completed by all the 5 persons will be 57.6 multiplied by 5, and it will give us 288. So we can say that in total 288 unit will be completed in 6 hours by all these 5 workers. Let's take the last example of this video, where a person purchased petrol at the rate of 14, 15.50 and 60 per liter during 3 successive years. And we have to calculate the average price of the petrol in 2 conditions. In condition 1, if he purchased 150, 160 and 170 liters of petrol in the respective years. And in the second condition, we have to calculate the average price of petrol if he is spending 2,200, 2,500 and 2,600 rupees in the respective years. Dear student, this is the best example to understand where we have to use the arithmetic mean and where we have to use the harmonic mean. Let's take condition number 1. Since the condition is given in terms of different liters of petrol in 3 years, therefore weighted arithmetic mean will be appropriate. We can use the formula of weighted arithmetic mean here to calculate the average price in condition 1, and it will be 14 into 150 plus 160 into 15.5 plus 170 into 16 divided by 150 plus 160 plus 170, and it will give us a value 15.21 rupees per liter, or we can say in condition 1 the average price of petrol was 15.21 rupees per liter. Now we will take the second condition. Since the condition is given in terms of different amount spent on petrol in 3 successive years, therefore weighted harmonic mean will be appropriate in this case. Or we can say the average petrol price will be equal to harmonic mean in condition 2nd. After putting values given in the problem in the harmonic mean formula, after calculation we can calculate the average price of petrol if a person is spending 2,200, 2,500 and 2,600 in 3 consecutive years. That will be equal to 15.179 rupees per liter. Dear friends, with this example, I think we have covered all the topics related to harmonic mean, and these are the sample questions along with their answer for your practice. I request you all, please try to solve these sample questions, and if you are facing any problem, please let me know in the comment box. At this point, I would like to thank to wisdomjob.com because most of the questions used in this video had been taken from this website only. Dear friends, you may have seen that during this video we have compared harmonic mean with arithmetic mean and geometric mean. So, for a detailed understanding, I request you please watch those videos as well. I also request you please watch my 2 other playlists, one which is related with measures of dispersions, or which is also known as secondary measures of central tendencies, as well as after watching both these playlists, please don't forget to watch the playlist of test of hypothesis. I will upload new videos related to that playlist very soon. Till then, like and share my videos, subscribe my channel, and don't forget to press the bell icon so that you will get the first notice whenever there is a new video on my platform. Thank you. Jai Hind. Bye bye.